One of the interesting problems of our project is that we want our neural network to learn and recognize patterns behind randomness. Because Farkle in itself is a game that's based on random dice rolls. And in order to be good at the game, you have to be able to make decisions that will result in a higher score, or at least be able to play by the rules of the game. And you can have a good dice roll, like the best choice that you could make, and have it result in a bad score, while also having a bad choice result in a good score. So this is just a very interesting problem that we want to tackle to see if a neural network could learn a game purely based on the concept of random. In order to even start working on a neural network that can learn how to play Farkle, we first had to kind of program the game itself. We started off by having something that can score dice. Let's see, where did it go? It's right here. Where ones will be 100, fives will be 50, a triple of any kind will be whatever that triple is times 100, and then triple ones would be 1,000. In order to create our neural network, we use TensorFlow, and we create the neural network inside of a class called player, as well as we're having a memory. This memory is a custom memory class that we created ourselves, where it will have a max memory size. Back over here we see that we did 80,000, and as we add to it, it makes sure that that number stays less than or equal to 80,000 by popping off things from the front while we're adding onto the back if we have new samples. As well as when we do sample, it's going to return a random amount of the number of samples that we want from our entire memory. And how this is going to help us is it's going to be what we train our neural network on. Neural networks usually need large amounts of data to train itself to be able to recognize correct answers and wrong answers. And because we don't have a lot of that, we built our own by having the neural network, or AI, play against itself and add samples to the memory. And as it does this, it retrains itself over and over. Lastly, we have the Game Runner class. What the Game Runner class is it's a player, which is our neural network, and the game itself, and it combines these two things. A lot of the code that you see inside of the run function is going to be statistics related, but the key parts that we should pick out is the game iterations, which I have set currently at 200, and the max game score, which is 10,000. So the neural network is going to play until it has this many points, and then it's going to start a new game. So it's going to do that 200 times. At the end of each game, it's going to train itself, where it's going to pull from its memory of things that it's done. It's going to make itself better at the game just from its past experience of playing the game. This is the result of our neural network training and learning over the course of 200 games. As mentioned before, the neural network trains in between each of these games, and that's why we see all these jutted spikes, is its results of how it learns and how it does not learn. The y-axis shows a percentage, and what this percentage is how much the neural network needed help. Because at the birth of a neural network, it doesn't know what it's doing, it doesn't know the rules of the game, it doesn't even know that there is a game. It's just making decisions based on the inputs that it has. And when it made an incorrect input that is against the rules of the game, what we did is we gave it a valid input and added that valid input to the memory, and then continued on. So, over the course of this neural network's life, it started to learn. And when it reached about 200 games, it only needed help about 9% of the time. This first line shows that in the first 3 rounds, it needed 61% help, and in the last 3 rounds that it played, in round 200, it only needed help 9% of the time. This is the result of running our code on 3,000 games, with our neural network training in between each of those 3,000 games. This graph, as you may have noticed, looks different from the previous graph that I just showed you. And that's because this neural network had to learn from different random inputs than the previous one did. But even though it's a different neural network, it's still learning the same general trend. As we see at the beginning, at the top left corner of this graph, it needed help about 90% of the time of all of the decisions it made in the first couple games. And over the course of its life, when it got to around 30,000 games, or not 30,000, 3,000 games, it needed help somewhere between 0 and 15% of the time. And this is something that we were really happy to see, that a neural network was able to learn a game that was based off of randomness. It was able to find the pattern behind random inputs. And that's what we set out to do. And we were happy to be able to prove that it's able to learn something. Anyway, thank you so much for watching.